Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes using the Solid Edge software. Coming to the problem statement, a pentagonal lamina of side 25 is resting on one of its edges on HP with the corner opposite to that edge touching VP, and the corner which touches VP is at a height of 15 above HP. Draw the projections of the lamina and determine the inclinations of the lamina with HP and VP and the distance at which the plane lies from the vertical plane. So this is the problem given to us. So we can understand a set of things here. That is, the given type of lamina is a pentagon and it is a regular pentagon of side 25 and the resting condition is it is resting on one of its edges on the HP. Coming to the inclination with respect to the HP, it is not given here, but the data given to us is the corner opposite to the resting edge is at a height of 15 above the HP. And then the next data, that is with respect to the VP, the inclination is not given, but however, the data given to us is the corner opposite to the edge on which it is resting is touching VP. So this is the data that is given to us. So the inclinations with respect to HP and VP is not given, but the details of the corner that is opposite to the edge on which it is resting is given to us, like at what distance it is above HP and how it is inclined, that is it is touching VP. So this is what is the data that is available with us. So with this data we shall see how to do the computer drafting of this particular inclination of the pentagonal lamina. So we will begin the problem solution by drawing the xy line of thickness 0.18 So let us draw a line of any arbitrary length and annotate this line as xy and also the reference planes as VPHP. So now we shall draw the top view of the pentagonal lamina. So the pentagonal lamina measures 25 So first we'll draw the pentagon and then we will rotate it as per the given condition. So it is 25 and the first angle is 72. So the next side is 25 and the next inclination is 72 into 2. The next edge length is 25 and the next inclination is 72 into 3. And next edge length is 25 and the next inclination is 72 into 4. So this completes the pentagonal lamina. So now we will select this entire pentagon and rotate it in such a way that one of its edges is there towards the right hand side of the observer. So this is the pentagon with one of its edges on the HP. So now we will annotate the top view of the pentagon as ABCDE, that is the corners. So this is corner A, this is corner B, this is corner C, this is corner D, and this is corner E. So now we shall draw the front view of the pentagonal lamina. So we'll take the projections from corner B through A and intersect the XY line. Again from corner C through corner E, intersect the XY line. And then from corner D, intersect the XY line. And we will complete the front view by trimming this part of the XY line and then drawing the front view with a line of thickness 0.50 So first point, second point, third point. We will annotate the front view. So this is corner B dash inside the bracket A dash, and here this is corner C dash and inside the bracket E dash, and here this is corner D dash. So this represents the 5 corners of the pentagon lamina and its front view. Now coming to the second part of the problem, that is inclination with the HP is not given. So but it tells that the corner opposite to the edge on which it is resting. So it is resting initially on the edge AB and the corner opposite to that edge is corner D. So as per the data that is given to us, this corner D is at a height of 15 above the HP. So this is the data to be used to mark the inclination with respect to the HP. So now we'll see how to do that. So first let us fit the sheet to the screen and then offset this line at a distance of 15 mm. So for that what we will do is we'll select this line and then we will use the offset option. First select this line and use the offset option, and the distance is 15 mm. So tell accept. It is asking the direction either above or below, so it is above. Correct. So it has taken the parameters from the previous setup, so just change the line thickness to 0.13 mm, and then this completes the offset of the xy line at a distance of 15 mm from the HP. So as per the problem statement, the corner which touches VP is at a height of 15 mm above the HP. So we'll be getting the front view at a distance of 15 mm above the HP like this. So now the corner opposite to the edge on which it is resting should touch this 15 mm. So what we will do is, initially we shall select the front view of the lamina along with the annotations, and then use the move option, ensure the copy is on. So keeping corner B dash A dash as the reference, just move it towards the right hand side of the XY line, and then we shall use the rotate option. So the first point of rotation is B dash A dash, the second point of rotation is corner D dash. And now we will rotate it until the corner D dash is going to touch this line. That is the line which is at a distance of 15 mm. So you can just use the zoom option to the maximum extent possible and check if the inclination is correct. So you can just see that there is a minute difference between the 15 mm line and this line, which is not intersecting. So if this problem arises, the best method of construction is, we shall just delete this. So we'll follow the manual method of drafting. That is, we shall measure this total distance, which is 38.47. So now we will go for the tangent arc and select arc by center point. So select any one particular point and then try to cut an arc of radius 38.47, and then cut an arc, and now complete the front view from the point of intersection to the center that is chosen, and this completes the inclination of the pentagonal lamina with respect to the HP. So we will use this annotation now. So this is corner B dash A dash, and this is corner D dash. So in the earlier method, the point D dash was not touching this 15 mm offset line, so we have used the other way of construction. So now to mark the endpoint C dash A dash, again we need to use the distance between option D dash C dash A dash. So it is 14.69. So we'll use this line option, and then on this line draw a line of length 14.69. So we get an endpoint here, and that endpoint is annotated as C dash E dash. So if you're not marking that point, you'll not be able to draw the projection line either from the left hand side to the right hand side or towards the bottom, that is the horizontal plane. So now we will complete the top view of this pentagonal lamina by drawing the projection lines from top to bottom. So from endpoints B and A, draw the projection line. Then from the endpoint C dash A dash, draw the projection line. And similarly from the corner D, draw the projection line. And now complete the projection lines from left to right. From each of the corner, take the projection lines. So ensure all those horizontal projectors are 0 degrees or 180 degrees and the vertical projectors are 90 degrees. And now we will complete the top view. So select the line of thickness 0.50, first point, second point, connect all the endpoints of all the lines and back to this endpoint. And now we shall annotate this. This is corner A, this is corner B, and this is corner C, this is corner D, and this is corner E. So always choose a clockwise or the anti-clockwise direction for nomenclating the endpoints, either A, B, C, D, E in this direction or A, B, C, D, E in this direction. Okay, so now this completes the top view whenever the corner opposite to the edge on which it is resting is at a distance of 15 mm from the HP. So now we will measure the inclination with respect to the VP, the horizontal plane. So we will select this line and the reference line. So 23 degrees is the angle of inclination with respect to the horizontal plane. So we can just trim the projection lines of unnecessary length. So we'll use the rigid set option. So select this pentagon and then in the relate menu select rigid set and tell accept. So this is rigid. Okay, so now what happens if you have not used the rigid option? So just for the example, see, this is what happens when you have not made your polygon rigid. So we can select the first polygon also and then make it as a rigid set. And now let us see what happens. Okay, we should have made this a rigid set before we drew the top view of this, so not a problem. Okay, so now we will use the second position to draw the next position. So it is better we make the second position polygon rigid. Okay, so now we can just delete this dimension because it is not required, but however show the dimension of one of the edges of the pentagon lamina, that is 25 mm. So as far as possible, try to ensure that the projection lines are not intersecting any of the uh, parameters like the corner annotations or the numbers, that is indicating the dimension of the length or the angle. Correct. So this line can also be trimmed. So now he tells that the corner opposite to the edge on which it is resting touches VP. So with that condition, we shall complete the inclination with respect to the HP. Select the pentagon along with the annotations and then select the move option, ensure the copy is on, and then keeping point D as the reference, just move the pentagon first and then rotate this. So whenever the corner D is touching VP, obviously AB should be parallel to the reference line. So now you can just see this dotted lines which is indicating the angle of 90 degrees. Correct. So now we'll again use the move option, but the copy should be off. Ensure the corner D is touching VP. You can just see that the reference line is highlighted. Correct. Okay. So you can just see that the corner D is touching VP. So I've told you all the annotations representing the top view shall be in the HP and that representing the front view shall be in the VP only. So ensure the corner D is marked here. Okay. So now we will draw the front view of this. So what is the procedure? So you can just see that the lines are overlapped here. So I'll just use a trim option and trim one part of the line. So now let me draw the projection lines from left hand side to the right hand side. So this is the line. So now from corner D, it has to touch here, and then corner E is here, corner C is here, corner A is on the XY line, and corner B is also on the XY line. So now we'll complete the front view of the rectangle by selecting the line of thickness 0.50 mm. So first A dash, B dash, next C dash, corner D dash, and corner E dash, and E dash to A dash. So now we will annotate this as corner D dash. This is E prime or E dash, and this is C dash, and this corner is B dash, and this is A dash. Okay, so now we can just trim the projection lines of unnecessary length. Okay, so with this we have completed the problem. We will just indicate the directions of the projection lines. So for that, we will select the leader option in the annotation menu and change the properties of the arrowhead from the green color to the black and click OK and indicate the directions. Okay, so with this we complete the problem. So to sum up, a pentagonal lamina of side 25 mm is resting on one of its edges AB, and the corner opposite to that side is corner D, and it is located at a distance of 15 mm above the HP. So with this we measure the inclination with respect to the HP, and then the same corner which is opposite to the edge on which it is resting is touching VP. So this is the corner D which is touching VP. Okay, and this is the front view of the pentagonal lamina. So the validation resting on one of its edges AB in the initial position, and even in the final position it is resting on one of its edges AB. So with this we complete the problem. Thank you all for watching.